is expected to grow from 8 billion to nearly 10 billion people. To provide all of us with the food, clothing, and infrastructure we need, we look to farmers and builders. When they go to work every day, they're faced with difficult tasks. They're responding to constant challenges, from ever-changing weather to a lack of helping hands, and often working late into the night. A job this hard isn't for everyone, but it is for everyone. They power through whatever comes their way, for their families, their communities, and everyone else who relies on them. From the food they grow to the materials they source, farmers and builders impact our lives daily. Even though we may never meet them, when we help them, we all benefit.
Please welcome Jamie Hyman.
Thank you all so much for being here, and welcome back to CES. Thanks for being at the press conference. I'm super excited to be back here 3 years from when we revealed John Deere's first fully autonomous tractor. And I'm thrilled to say that these tractors are already being used by farmers to prepare the soil for seeds to be planted next year. That was a giant leap forward 3 years ago, and today we're going to take another giant leap forward in John Deere's autonomy journey. Actually, we're going to take 4 giant leaps forward. But first, let me share 3 key reasons why we're on this path. First, the customers we serve every day in agriculture, construction, commercial landscaping have a wide variety of challenges in their work. One challenge they all face is limited labor availability. Not only has this been an issue recently, it's been a challenge for much of the last 2 decades. And there are many factors that contribute to the labor gap, things like rural to urban migration and an aging industry demographic. But regardless of current events, this has been a persistent challenge that we are intent on solving. Because our customers all have work that must get done at certain times of the day or certain times of the year. And there simply isn't enough available and skilled labor to do that work in a timely and efficient manner. Let's look at some facts. In the US, the average farmer is over the age of 58, and each day they're putting in 12 to 18 hours to grow the food for all of us. The American Farm Bureau Federation estimates that there are roughly 2.4 million farm jobs that need to be filled annually, with that agricultural workforce continually shrinking. In the construction industry, 88% of contractors are struggling to find skilled labor. Meanwhile, those contractors are tasked with closing the world's $15 trillion infrastructure gap by 2040. Somehow, they have to figure out how to do more work with fewer people. And for landscaping, 86% of business owners struggle with finding the labor to fill their open positions. Labor is a common challenge across these industries, yet we rely on all of them to provide the food, the fuel, the fiber, and infrastructure, landscaping care that all of us depend upon every day. This is the kind of challenge that we love to work on and solve for our customers. We believe autonomy can be a part of that solution. Second, the pace of our autonomy solutions is accelerating. We're taking our tech stack, which is nearly 3 decades in the making, and we're extending it to more of our machines to safely run autonomously in unique and complex environments that our customers work in every day. Just because a farm doesn't look anything like a rock quarry or an office park doesn't mean we can't deploy the same or similar technology across the machines that are operating in those environments. Third, when we talk about autonomy, we mean full autonomy. No one's in the machine. Using John Deere Operations Center app on a smartphone, customers can interact with the machine, they can monitor the machine's activity, and they can see performance data. They watch the work being done, but they don't have to worry about who is going to do the work today. Our autonomy solutions are doing real work for real customers, and our customers demand that the safety and quality of jobs these machines do autonomously is at least as good, if not better, than the job performed when someone is sitting in the operator's seat. It's helping them solve the problem of finding and keeping skilled labor for their business. Our customers in all the industries we serve need this, and we're excited to show you our evolution of autonomy. We've got a great team here today to talk in depth about our autonomy efforts. I'm going to turn it over to Willie, Matt, Agino, and Maya to talk about our path forward.
So a few years ago, right here at CES, we introduced our first autonomous tractor. Now, most autonomy projects never get beyond the demo stage because 9 times out of 10, the culprit is just too much scope. So we stripped everything down to the smallest scope possible because if we couldn't do that, there was no point in going any further. Well, we've done that. We started with the slowest, easiest, least time-sensitive job on the farm, which is fall tillage with a chisel plow. Now we're excited to spread our wings beyond this initial use case.
Our first generation architecture employs stereo cameras. And we use stereo cameras because it provides depth or distance information in computer vision. So the way this works is when an object is viewed by 2 coplanar cameras, there's a slight angular offset in each of the image spaces. So with knowledge of the system geometry, we can compute the range to that object using triangulation. One common technique for doing this is called rigid baseline stereo camera. In a rigid baseline stereo, the 2 cameras are separated and held positionally and orientation-wise from each other mechanically. To increase the sensing range in a system like this, we have to widen that baseline. So widening that baseline makes it harder and harder to preserve those angular orientations between the cameras.
Mechanical tolerances and vibration and temperature swings effectively limit how far you can sense at some distance accurately. So to solve this, we created what we're calling camera arrays. Instead of 2 cameras overlapping, we have many cameras overlapping. So each camera can correct the position and orientation of every camera every single frame. This allows us to let go of these critical mechanical assumptions and embrace inevitable camera movements. And this real-time calibration allows us to run with wider baselines and have more accurate depth at greater range.
Yeah, in a nutshell, it allows us to see further. And seeing further allows us to drive the machines 40% faster and pull implements twice as wide as before. These are substantial increases in productivity and adds more value through time savings with autonomy.
So this new kit, which could be retrofitted onto existing large tractors, will be able to do every job a tractor does on the farm. That is fall tillage, spring tillage, planting, and grain cart operation. And this will alleviate farmers from the acute labor availability constraints throughout the entire year.
Yeah, and farming never stops. The environment that our machines operate in is unforgiving. So the hardware components in this second generation autonomy kit need to be just as durable as the tractors and implements. So these components, they feature the latest technologies in computing and imaging, but are passively cooled and ruggedized for work in a harsh off-road environment.
So we perpetually process every single pixel of every image from 16 cameras to keep the machine safe and productive. Data generated from the perception system is fed into NVIDIA-born GPUs. And inside these GPUs, we calibrate the cameras relative to one another, infer the semantics of each pixel using transformer networks, and make the right decision in real time. The images you're seeing here are a small handful of strange things we encounter while running autonomously. By training models on these images, our machines become more experienced and run more safely and more productively. And when we first designed the system, we did not have insects in mind as a class of object to train on. But when you run a tractor at night with the lights on, a moth weighing less than a single ounce would bring our 40,000-pound machine to a halt. It was a software bug in all senses of the word. Autonomy is all about solving the long tail of edge cases, bugs being one example. And each of these images is an experience that helps more than just our large ag machines. We're building data and tech stack that is modular, and we're spreading it laterally across our machines for customers in all the industries we serve. Gino is going to come out here and tell us about one such case. So welcome to Gino.
Thanks, Matt and Willie. Thanks for being here, everyone. This is incredible. So the impact of our second generation technology is immense. And what it allows us to do is scale autonomy not only to different types of machines, but also to new crops, and as you'll see, even new industries. So today, we're bringing autonomy to high-value crops. So let's get to our next two announcements. Now, high-value crops are different from the traditional rolling corn and soybean fields that you might be familiar with in the Midwest. And they include things like fruits and vegetables and nuts. And as you may know, California is one of the largest producers of high-value crops in the world. In fact, about 90% of all tree nuts grown in the United States are grown in California. And 77% of the world's almond production also comes from the Golden State. The problem is, California growers are facing a severe labor shortage. Now, almost half of all available equipment operator jobs in the state are currently unfilled. And a major reason for this is that those jobs are among the most physically taxing and grueling jobs available. Now, one of the most challenging jobs for California farmers to fill is also the most frequent: air blast spraying in tree nut orchards. The work is exhausting and it's repetitive, but it's absolutely necessary to protect those trees from pests and disease. So in order to do this job, workers need to drive up and down endless orchard rows for up to 10 hours a day at 2.5 miles an hour. Every single tree in that orchard needs to be sprayed at least 6 to 8 times per year. So that means the workers are starting in February and going through July or August, right in the hottest time of the year. And to make matters worse, the kicker is all of this needs to happen at night. Thankfully, technology can help.
The feeling I have when I walk down my fields is pride. I walk these fields every day. To see a crop grow is inspirational. Every year I grow about 10 million pounds of almonds, walnuts, and pistachios. My name is Russell Michael. I'm a tree nut farmer in Northern California. Growing walnuts, almonds, and pistachios is a complex job. It's ever-changing. You have to stay up on top of new technology. During harvest, it's not uncommon for me to work 14 to 18-hour days. Never in my life did I expect an autonomous
So today, our team is extremely extremely proud to reveal 2 new orchard tractors. Now, there's a lot of similarities between our autonomous tillage solution and our autonomous orchard solution. They both use our 2nd generation autonomy kit, and that's built on the John Deere tech stack. And that means they share things like consistent hardware and cameras and even user interfaces. But there's also sufficient differences in the environments that these tractors operate in that require a unique approach. So, unlike tillage, which takes place in these vast, open fields, orchard tractors need to navigate through dense canopies with trees that are up to 30 feet tall. That's much taller than the tractor itself, and the density of those branches create challenges for traditional GPS. And so these challenges require a different approach for obstacle detection and navigation. So in addition to the 7 cameras around the tractor, we've also introduced LiDAR sensors as well. Now, LiDARs provide depth information, and that allows the tractor to know where the trees are and how to navigate between them. So that ensures the tractor can drive straight down the road while identifying what is or isn't an obstacle, which is much trickier in this environment. So, if the tractor sees a human, or a pickup truck, or irrigation piping, or a bee box, like literally a hive of pollination bees, you're going to want to avoid that. It knows whether it should stop or drive around the obstacle. So one of the coolest visualizations is what the tractor sees through its LiDAR sensors as it's going down the road. So let's take a look. This is what humans would see. And then over here, you can see the tractor has identified the trees, put red bounding circles around them. It can see small obstacles. And you can even tell the tractor is calculating the optimal route through that orchard many times a second. Now you may have noticed that our 2nd tractor looks a little bit different. And that's because this one is fully electric. So this fully electric tractor is powered by up to 5 immersion-cooled batteries. And that means that farmers can not only meet their operational needs, but also achieve their sustainability goals as well. Plus, fuel costs, maintenance costs, and maintenance downtime are all reduced by about half. Today, we're testing this electric tractor with real customers and real orchards, and our plan is to introduce autonomy as we scale the pace of autonomy across our fleet. So as I said, we're extremely proud and excited to help farmers like Russell change how they farm while seeding the future of autonomy in more orchards. But the impact of our technology goes well beyond the edge of the field. And to talk about that, I'd like to introduce my colleague, Maya Sherpato.
Thanks, Gio. So let's talk about a different industry that Deere serves. I want to begin with a question. Who here has been to a quarry? Okay, not a lot of people raising their hands. They're fascinating places. They give us access to raw materials that we rely on every day. Think about your eyeglasses, makeup, and even the toothpaste that you used this morning. These common items contain raw materials supplied by quarries. In fact, a customer once told me, if it's not grown, it likely comes from a quarry. Quarries are extremely common. In fact, there are 8 of them within a 12-mile radius of the Mandalay Bay. Now, before I geek out, I want to touch quickly on the big picture. The world's population is expected to grow from 8 billion to nearly 10 billion people by 2050. Not only does that increase demand for food, but it also increases the need for roads, homes, and buildings. According to the UN Habitat, we need to build 96,000 new homes per day in order to provide enough housing. Quarries supply the materials to build those homes. A quarry can be thought of as an outdoor factory, where machines work together in an ensemble to move thousands of tons of material per day. Each machine is responsible for completing different tasks. Together, they move materials from where it's sourced to processed to eventually shipped. And today, I want to focus on one machine, the Articulated Dump Truck, or ADT for short. It's tough to operate this dirt conveyance vehicle. The job is difficult, repetitive, and uncomfortable. And the entire operation depends on dirt getting from one point to another via this truck. The truck operator is expected to handle precise coordination through rudimentary communication. So think about this. Think about driving your car today. You're on a smooth asphalt road with GPS telling you where to go and ABS keeping you safe. ADT operators don't have this. They're using a walkie-talkie to move 92,000 pounds of material around a rugged site and are expected to keep themselves and everyone else safe while doing it. So, for reference, 92,000 pounds is around 7 African elephants. That's just an insane amount of material. Quarries have to stick to a strict schedule. All day and sometimes all night, the ADT is running laps, loading, hauling, and unloading material. Throughput is measured hourly and daily, and if one machine falls behind, it impacts the productivity of the entire operation. The articulated dump truck has a high likelihood of falling behind. Think about this. If an operator can't make it to work or gets pulled into another job, a domino effect occurs, and it wrecks our customers' output. That's where our next autonomous solution comes in. In an industry where success is measured by everyone leaving work safely at the end of a productive day, the opportunity for us to make a real impact with autonomy is tremendous.
If you told me there was going to be an autonomous machine in a quarry 20 or 30 years ago, I'd have looked at you like you were out of your mind. Everything comes from a quarry. The water purifications, foods we eat, clothes we wear, the houses we live in, to the roads that we drive on. It's a part of our everyday lives. I'm Russell Hatfield, and I manage a quarry in Las Vegas. 20 years ago, we were probably pushing 120 tons an hour, and today we're mining 350 tons an hour at 375. The demand has really grown. We run 24/7. We run like on a 4-shift basis. The larger the quarry, there's many new challenges: safety, employment, and training. Finding skilled labor is very challenging today. I mean, it doesn't seem like there's any vocational schools that teach it. To be able to run and see a machine and be able to operate from my desk while eliminating training, eliminating safety factors, you want everybody to go home safe. It's going to increase productivity out of the mine and give me more time to be more creative of what we need to do in the future. The truck and autonomy will run 24/7. You don't have to shut down, you don't need to stop for a break. It frees up the operator, and again, that's where I mean you'll get that growth and that extra help to keep moving forward. Autonomy is the future, and I'm ready for it.
We're expanding Deere's autonomous portfolio into construction for the first time. Meet our fully autonomous ADT, or as our team would say, meet Dusty. This big-ass truck, and yes, it really is this big in real life, is one of the many types of big earth-moving equipment that we manufacture in Davenport, Iowa. This machine leverages the same autonomy stack as its autonomous farming siblings. It starts with high-performance electronics, designed and tested by John Deere for over 30 years to operate in Earth's toughest environments. The ruggedized component stack includes satellite internet, advanced controls, and high-performance GPUs, which enable us to deliver real autonomy into the rough and dirty world of construction. Then, we add our second-generation autonomy kit on top, which provides a 360-degree view of what's around the machine. We can't ignore the differences between a field and a job site, right? They look very different. And that prompted us to build new capabilities into our tech stack. Job sites are both dynamic and busy. Routes change, vehicles share the road, and they move within the same space. So to account for this, the autonomous truck has the ability to dynamically adjust its path as it travels along the road. And the machine makes these decisions as intuitively as a human operator. Additionally, in a quarry, machines work together to complete tasks. So we'll introduce another capability to support orchestration between man and machine. Currently, John Deere Operations Center is the operating system for the farm. We're extending Op Center to become the operating system of the job site as well, allowing customers to interface with their autonomous teammates. An example of this in practice, when the ADT reaches a loader, the loader operator will be able to communicate with the autonomous ADT about location and timing. Let's take a look at what the machine sees and thinks as it's driving through the quarry. This video is taken from one of our active test cooperators, Martin Marietta, who's here with us today. The machine starts with being loaded. The loader operator has access to vital signs of the autonomous truck via Op Center. Once it's done loading, the truck is released back onto the active haul route. Now the machine begins traversing autonomously. It's using Starfire GPS to localize itself on its road as it follows the path between the load zone and the unload zone. These map attributes are specified and customizable by the user via Operations Center. As it's driving, it's leveraging those camera arrays Willie and Matt talked about to segment the world. If the machine sees something, we use computed depth to determine how far away the object is and whether it needs to change course. Now, the mission comes to an end and we see the ADT reaching the unload zone where it will dump out the materials. It positions itself, dumps, and sends a message to other folks on site, letting everyone know Dusty's finished his cycle fully autonomously. The truck will head back to the loading area and repeat, and our customers can analyze productivity from their phones. Overall, Deere Autonomy will support how our customers' operations currently run today, maintaining our commitment to build high-trust, high-performance products. I'll leave you with a quick closing thought. When we walk into a hospital or take off in a plane on a runway, we rarely think about the input required to build these places. We just enjoy the fact that it's there. Deere is taking some of the most advanced technology on Earth, autonomy, and deploying it for people who have been working behind the scenes for generations to build human infrastructure. 10 years from now, when a child learns to brush their teeth for the first time, their toothpaste and toothbrush will likely be produced with the help of an autonomous ADT. I hope autonomy also helps make the customers that will benefit from this tech more visible to more people. Now, I'll pass the mic back to Jamie to close this out. Everybody.
I hope you all can see the impact that autonomy can have on agriculture and construction. But there's also one other area of Deere's business that doesn't get talked about as much: commercial landscaping. Our public and private landscapes require a lot of care. And we've been in the business of making lawn equipment for over 60 years. Think of all the green open spaces like office parks and industrial complexes that you see on a regular basis. Those places need to be mowed every week, and they can be massive spaces that take a long time to mow. For people to enjoy these areas, it means they usually need to be tended to early in the morning, and finding people to do the work is challenging, especially when there are so many other things that need to get done every day, from caring for the trees and other landscaping activities. Our customers in the commercial mowing industry compete in an intense bid process to win their business. The key to winning a bid is being able to mow the property throughout the complete year. So when those customers inevitably face short-staffed and workforce challenges, autonomy provides them with a solution. And that leads us to step number 4. Today, Deere is revealing a new autonomous commercial mower. Our autonomous mower uses the same second-generation autonomy technology as the tractors and the articulated dump truck you just saw. But since the machine is smaller, it doesn't need as many cameras. This mower features 4 pairs of stereo cameras, one in the front, one in the back, and one on each side. And they're positioned as high as possible on the machine to give us a complete 360-degree view around the mower. And by the way, this mower is also fully electric. So in addition to reducing emissions, it's also reducing noise pollution for people who live and work nearby. These are the 4 steps we're taking to Deere Autonomy's journey today. We're bringing real autonomy to more machines, more jobs, and more customers. But this doesn't just happen. It's the result of our tech stack that has been built by amazing technologists over decades, which allows us to accelerate the pace of autonomy. It's the result of our teams building and refining technology, taking data, intelligence, and learnings from one machine and applying it to other machines. And it's the result of listening to our customers and creating real solutions that meet their needs. In food, roads, landscapes, there's something that we can't take for granted: There's two important points I want to leave you with. The first is we want to make autonomy available to industries that can benefit from it. So not only will we offer autonomy on our new machines, but our customers can also add autonomy kits to many existing Deere tractors, articulated dump trucks, and commercial mowers. This will help farmers, contractors, and landscapers bring autonomy to their current machines, putting them in a better position to invest in new machines as their businesses grow. Second, all of the technology we just showed you is really, really cool. But creating cool technology isn't what we do. What we are doing is creating real solutions for our customers' real needs. We rely on these businesses every day to provide food, fuel, roads, and the landscapes that we all enjoy. They are our purpose. And we're honored to have some of our customers here with us today. Dustin, Russ, and Serge all operate quarries. And Russell, who you saw in the Orchard video, and Jackson, who is John Deere's chief tractor kid, but you might know him better as just a Jackson thing on TikTok, represent two generations of farmers. Could you join me in thanking them for everything they do and being here? I would like to thank all of you as well for joining us. I'd ask that you come visit us in West Hall this week and learn more about this amazing technology for yourselves. Thank you.